Hello, welcome back. So today we are going to see some questions on circles. And so these questions we are going to understand from a perspective that we want to make them easy for you. Okay. So this is one of the chapters which I like very much, right? Because the questions are very easy. You just need to remember the trick and you're able to solve it. And the tricks are very few here in circles. So I hope by the end of this, you'll be able to learn this circles chapter in a very good way. Okay, so let's see the first question. So L and M are two parallel tangents at A and B. So if you see here, L and M are two parallel tangents at A and B. The tangent at C makes an intercept DE between L and M. So at C we have another tangent which has intercept of D and E at L and M. Okay, so we have to prove that angle DFE is 90 degrees, what we have to prove here. Okay, so let's see how we will do this. Okay, so in this question, let's see what I have done already is I have drawn these radius from, let's say, center F, from F to C, F to A and F to B. Okay, so this is 90 degree we know, this is 90 degree we know, this is 90 degree. So in questions of circles, you write whatever you already have. Once you write it, it will become very easy for you to understand and do the questions afterwards. Okay, so let's proceed now. So what we are going to do now is, uh, yeah, so these are parallel tangents, right? So parallel means, and these angles are equal 90 degree. So it means this is the, uh, this is AB is the center, AB is the diameter, right? Uh, okay, because these alternate angles, corresponding angles are same here. Okay, so now what we're going to do is we are going to see these two triangles. Now see, I have to prove this angle is 90. How do I do that? So I have different ways. So first, one way I can do is, I'll discuss only one way now. So let's discuss what we are going to do. So we have this triangle AFD. Let me write it here. AFD and triangle DFC. So these two triangles we have now. Okay. So what we are going to do is we are going to see whether they are equal triangles or these are congruent triangles or not. Okay. So um, so this point D is sending two tangents DA and DC. If you see here, so therefore we know that tangents coming from the same point, two tangents coming from the same point to the circle are equal. So by this AD equals to DC, right? And AF and FC are radius, so these are also equal. Plus FD is common, right? So using these three, what you can say, this is triple S property, right? Triple S is triple S congruence. So all of these are equal. So that means these triangles are congruent. When I say congruent, and even these angles, if you see, these are 90 degree, right? So RHS is also applicable here, right? So let me just remove this and we'll say based upon RHS. Okay. Huh. So FD equals to FD, right? And based upon all of this, I can say by based upon triple S congruence, these triangles are congruent. Now, if you see these angles are 90 degree and angle 1 and angle 2 are also equal because these are corresponding angles of the triangle, right? So, what I'm going to do is angle 1 plus angle 2 is 90 degree. Sorry, angle 1 equals to angle 2. I'm really sorry. So, from here we are going to get, so from here we are going to get angle 1 equals to angle 2, right? Similarly, if we see here angle 3 and angle 4 in these two triangles also, you can prove the congruency like the same method. So I'm not going to do it. You can do it on your own. Now, this is one thing, right? The second thing that we have got is angle 3 equals to angle 4. This is again the same way. We have found these triangles are congruent, therefore angle 3 and angle 4 are equal. Now, other point that we want to understand is this particular line that we have, it's a straight line, right? Now, 1, angle 1 plus angle 2 plus angle 3 plus angle 4 is 180 degree, right? We know a line can have 180-degree angle on one side, right? So that's what I have written here. Now, based upon 1 and 2, what I'm going to do is I'm going to write angle 1 as angle 2, angle 3 as angle 4. So what will happen is angle 2 and angle 4 will come twice now, equals to 180 degree, right? So angle 2 plus angle 4 becomes 90 degree. And that's what we had to prove, right? DFE is 90. So DFE is 90. So that's what we had to prove here. Hope you understood. It's so easy, right? Okay, so this first question is done. I'll go to the second question now. Okay, so in this question, what we have is we have a tangent at point C in this circle. So if I draw this line, so this is 90. This is what we are given on the first line, and AB is a diameter, right? And when extended intersected, and so diameter and tangent, when they are extended, they meet at point P. If angle PCA, so this bigger angle, this is how much? This is given as 110 degree, right? Now I have this angle is 110. Now I have to find angle CBA. This is what we have to find out, and we have to also find out angle BCO. Okay, so now the question is pretty simple. Okay, and if you remember what you have studied till now, you'll see the answer already. So this bigger angle is 110. This angle is 90, right? So what is the next thing that I can do? I can do is I can find out this particular angle. So this becomes 110 minus 90, which is 20 degrees. So just to let you know, I am finding angle OCA, which is equals to angle PCA minus angle PCO, right? So PCA is big angle minus small angle, which is this, which is again 90. So if I do this, 110 minus 90 degrees, and it becomes 20 degrees. So this angle is 20. Now, if you see, these are the two same points which are, okay, so this is 20. Now consider this particular triangle. In triangle OCA. So this and these are same, the both are radius, right? So this also becomes what? Same angle, 20 degree only. This OC equals to OA, right? So that's what we have said, both are radius. Therefore, angle CAO equals to angle OCA, which is 20 degree, right? Now, what I'm going to do is, I know this angle, I know this angle. Again, what I'm going to do is, I'm going to find out this angle. So what is this angle? Sum of all the angles is 180 in this triangle, right? In triangle OCA, angle, okay, let me write it down. 1, this is 2, and this is 3. So angle 1 plus angle 2 plus angle 3 is 180, right? So angle 1 is, we don't know angle 1, but we angle 2 and angle 3 are both 20 degree, right? That's what we have written here. Now I'll just add and subtract it from 180. So angle 1 becomes 180 minus 40, which is 120 degree. Now angle 1 is 120, and we have to find out this particular angle. How do I do that? So if you see angle C and A, they are subtending angle 120 at the center. And if the same points subtend another angle at the circumference of the circle, it is half of the angle which is present at the center. So this you might have already studied, right? So angle CBO is equals to half of angle COA, right? So angle CBO we need to find out, and this is half into 120, which is 60 degree. But you remember one more thing, in this particular triangle BOC, so in triangle BOC, we have OB equals to OC. So both are radius, right? So angle CBO and BCO are also equal. This and this are equal. So both are 60 degree. We have to find CBA. CBA is nothing but CBO only. And BCO. BCO is again we have found out just now both angles are equal and 60 degree. Hope you understood. It's an easy question. Okay. So coming to third question here. PB is a tangent to the circle center O at B. So this is B and we have a tangent here, right? BP, and the circle of center of the circle is O. Now AB is the chord of the circle of length 24 centimeter. So this is the chord with length 24 centimeter and at a distance of 5 centimeter from the circle, from the center of circle. So from center of the circle, the distance is 5 centimeter, right? And if the length of tangent is 20 centimeter, so this is 20 centimeter that is given, find the length of OB. So okay, from here to here we have to find out, right? What we are going to do here, I mean, see, it's not, I mean, this might look a bit difficult question, but it's very easy. All you need to do is whatever you know about the diagram, you just write it down and you'll be able to find the answer. Okay, so this is the chord. We'll start with the chord. We have chord as AB and the center distance from the center is 5 centimeter. So let me just draw radius where we have this B or BP as a tangent as well, right? So in triangle OB and let's say OBX, okay? So we have this as right angle because distance, when we have to find out a distance from the center, we always drop a perpendicular. So we can say OX is a perpendicular on AB. So therefore, OX is 5, XB is 12, and we have a right angle here. So this is hypotenuse, radius is the hypotenuse here, right? So we have OB square equals to OX square plus XB square. So this is square equals to this square plus this is square, Pythagoras theorem, right? Simple Pythagoras. So this becomes 5 square plus 12 square, which is 25 plus 144, which is 169. And therefore OB becomes 13. So radius becomes 13 here now. This is one thing we have found out. Now we have to find OP as well. Now it is very simple. You don't need to do anything. So in triangle OBP, what we are going to do? We have again a right angle triangle. We have two sides as 13 and 20 and we have to find out the hypotenuse, right? So here again we'll apply the hypotenuse Pythagoras theorem only. So OP square equals to OB square plus BP square. So OP square we have to find out. OB square is 13 square plus 20 square, correct? So it becomes 169 plus 400, which is nothing but 569. So based upon this, we can say OP is nothing but root of 569 centimeter. So we can leave it like this only because this is not a perfect square. Okay. So OP becomes 569 centimeter, root of 569 centimeter. So I hope this is also clear. It's very easy question. Okay. I'll go to next question now. Question 4. Rectangle ABCD circumscribes a circle of radius 10 centimeters. So let's say this is rectangle AB, C and D. So in rectangle, when we say rectangle, let's try to plot whatever we know already. So from the first sentence itself, we know this is a rectangle. So when you say rectangle, these are 90 degrees, right? I hope this is clear. There are only two figures which have 90 degrees. All of the angles 90 degrees. Rectangle or square. So here it's a rectangle. So in that case, AB and BC might be of different length. Uh, okay, this is not price but proof. Prove that ABCD is a square. So we already know ABCD is a rectangle, and we know from center the radius is 10 centimeter. Okay. Now, if you know, so we have to prove that this rectangle is a square. That's the first thing that we have to do. And we also have to find the perimeter of ABCD. Right? We have to find the perimeter. So these two things we need to do. First is proof, and the second is the perimeter. So let's say how to do this. So this is our radius. So these are 90 degree again, right? So we'll start with whatever we know already, right? Radius is 10. This is rectangle, and these sides are touching the circle on, let's say, PQRS, PQR and S. So OP and OS are perpendicular to the sides. So these are 90 degree. And since it's a rectangle, ABCD is a rectangle. So angle ABC is also 90 degree. Now, if you see, this is a quadrilateral which is having three angles as 90 degree. So if three angles is 90 degree, fourth angle has to be 90 degree, because sum of all the angles is 360, right? In a quadrilateral, the sum of all the angles is 360 degree. So again, therefore, angle O becomes 90 degree again. Now, if it is 90 degree, there are only two possibilities. All the angles are 90 degree. So either O, P, B, S is either a rectangle or a square, correct? Now, if you say rectangle, rectangle means the sides, the consecutive sides or the neighboring sides, they should be of different length. But if you see here, OP and OS both are radius, they cannot be different. So they are same. So this is not a rectangle as such, but a square. So OPBS is a square. So if we are saying this is 10, all of these are 10, right? Now, since we are saying, I mean, like whatever we have done in this particular square, we can do it again with others three parts left as well. And the same thing will come there as well. So all of these will be 10 only. Hope you are getting this part. This is very important. So OPBS, we have find out that it's a square. So length of PB becomes 10. If you see, if I create a square here, if I create a quadrilateral here, again we have the same thing, right? All angles will be 90 degree. Since all angles are 90, so it's a rectangle or a square. But if you see here, both are radius, both cannot be different. So both are 10 centimeter. So therefore, it's a square. Therefore, I've written 10 here as well, and similar to the other sides as well. Therefore, AB becomes AP plus PB. Now, AP is 10, PB is 10. Therefore, AB becomes 20 centimeter. Now, if you see, all of them are 20 centimeter each. So AB is 20, and BC, if you see, is again 20. So it's it is saying rectangle ABCD is a square in the question, but it's not a rectangle as such, but it's a square. So ABCD becomes a square, right? That's the first thing. That's what we had to prove, right? Lengths are equal and angles are already 90. So therefore, since AB equals to BC, therefore, neighboring sides are equal and angles are equal. Therefore, angles are 90 degree each. Therefore, it's a square. Now, to find the perimeter, we already have the length of all the sides. We can use only one side. Perimeter of a square is 4 into side, which is 4 into 20, which is 80 centimeter. Hope you understood. It was an easy question, right? Circles questions are very easy. You won't find any problem. If you'll just write down whatever is given, we'll be able to solve the questions. Okay. And this is the last question now. So TP and TQ are tangents drawn to a circle with center O, right? So TP, if you see, this is T. TP and TQ are tangents to the circle with center O. if angle OPQ is 15, so angle OPQ, this is 15 degrees, and PTQ, angle PTQ is theta. Find the value of sine to theta. This is what we have to find out. Just let me write it here. Sine to theta we have to find out. Okay. So again, if you see here, the question is very simple. You can do it very easily, right? So let's, do you want to try once? Take 2 minutes and try to solve the question. You can pause the video. Okay. So I hope you have tried, okay, and you are able to solve the question. If not, let's do it together. And if you have done it, let's verify. Maybe your way of thinking is a bit different, and it's easier from my side, from my way of thinking, right? It's possible. So we have angle OPQ is 15, right? And these OPQ is equals OP is equals to OQ. So therefore both angles are 15. So in triangle OPQ, OP equals to OQ, both are radius, right? Therefore angle OPQ equals to angle OQP, which is 15 degree each, right? Now if you see, angle OPT is 90 degree. It's a it's a radius touching the tangent, right? So it's 90 degree angle. So angle OPT equals to 90 degree, and angle OPQ is 15 degree. Therefore angle TPQ becomes 90 minus 15, because from the whole angle I'm subtracting this part, I'll get this part, right? 90 minus 15, which is nothing but 75 degree. So this is clear. If this is 75, and we don't even need to find this 15 actually. So from TP equals to, so these are two tangents coming from the same point, which is T, right? So angles they are subtending in this circle, again they will be same. So in triangle TPQ, angle P is 75, TP equals to TQ, because these are tangents from same external point. Therefore angle Q also becomes 75 degrees. This is also 75 then, and that this seems right because we have this whole angle as 90 degree. This is a radius on the tangent, right? So it becomes correct. So both of these angles we have found out now. So now what we are going to do is, we are going to add all these three angles of this triangle. So angle P plus angle T plus angle Q equals to 180, right? This is all clear. We have sum of all the angles of a triangle is 180. So this is 75 plus T we don't know, which is theta actually. I'll write theta here. And angle Q is again 75. So sum is 180. So therefore theta becomes 180 minus 75 plus 75 is 150. So theta becomes 30 degrees, right? Theta is 30 degrees, and we have to find out sine 2 theta. What is sine 2 theta? Sine 2 theta is sine of 2 theta. 2 theta is 2 into 30. We have to find out sine 60. Now if you remember the table from trigonometry, if you remember, it's 0, 1 by 2, 1 by root 2, root 3 by 2, and 1. So this is sine table for 0, 30, 45, 60, and 90. So sine 60 is nothing but root 3 by 2. So our answer is root 3 by 2. Hope you understand. So I hope you understand this part as well. Sine 60 is root 3 by 2, and that is our answer. So we have done 5 questions here. We have done 5 questions for circles here, right? Uh, so the questions are very easy. You just need to write down whatever is given in the question, and you will be able to find out the answer. Okay. But in case you face any problem, you just add a comment in the video, and I'll try to solve this solve the question that you have, right? And additionally, if you want any other question that you want me to solve, you put that in the comment as well, and I'll try to pick it up. Okay. So hope you have a good understanding of circles now. We'll have one more video for I think 4 or 5 questions more, and you can have a look at that as well. So I hope you understand this part as well. Sine 60 is root 3 by 2, and that is our answer. So we have done 5 questions here. We have done 5 questions for circles here, right? Uh, so the questions are very easy. You just need to write down whatever is given in the question, and you will be able to find out the answer. Okay. But in case you face any problem, you just add a comment in the video, and I'll try to solve the question that you have, right? And additionally, if you want any other question that you want me to solve, you put that in the comment as well, and I'll try to pick it up. Okay. So hope you have a good understanding of circles now. We'll have one more video for I think 4 or 5 questions more, and you can have a look at that as well. Okay. See you next time. Bye bye.